So right after knowing about ionic compounds, naming them and writing its chemical formulas for both binary and ternary ionic compounds, now we're off to the second type of compounds, the covalent compounds. So covalent compounds are basically, these are the compounds that are all composed of nonmetals, and these nonmetals share electrons compared to ionic compounds, which they lose and gain electrons. But for this, it's all nonmetals that share electrons. Therefore, when they share electrons, we should not simplify the subscript values of these compounds. No simplifying, simply because that each surrounding atom to the central atom will contribute to the stability of your compound. And your covalent compounds actually are the easiest to name and to write its chemical formulas. Why? Because you will just be using the subscript values. So when you use subscript Greek prefixes, when you look at the subscript to be 1, you use the prefix mono. These prefixes actually are very familiar to you because these are the prefixes that we use for hydrates. The hydrates were the ones with .H2O, and there's a coefficient that will tell you how many there are. That's the same with covalent compounds. If you see that you don't have any subscript, that's understood to be 1, therefore you use the prefix mono. However, you need to remember that for this prefix, the mono cannot be used to the first nonmetal that is written in the chemical formula. You can only use the prefix mono for the second nonmetal element in the compound. But the rest of the prefixes, starting with di until whatever numbers that is, you can already use that to the first and second element, non-metal element in the compound. So let me show you examples on how to uh, apply our prefixes in naming our covalent compounds. So again, these are mono, di, tri for 3, tetra for 4, penta for 5, hexa 6, hepta 7, octa is 8, nona is 9, deca is 10. So let us now look at some common examples. When do we use mono? Now, the example here is NO. You have one nitrogen and one oxygen. Now, you look at the name. The name is just nitrogen monoxide. We did not say mono nitrogen monoxide. Remember, I told you that the prefix mono cannot be used for the first non-metal element. So, the first non-metal element written in the chemical formula. If it's just 1, you just retain its name with no prefix. That's understood to be 1. However, you can already use the prefix mono to the second non-metal element. In this case, it is oxygen. And since it's the second non-metal element, which is the same as the binary ionic compound, that non-metal should end in IDE. So the name is nitrogen monoxide. Remember, we cancel out one O from the prefix mono because oxygen starts with letter O as well. So you cancel out if there are two the same vowels. So it's going to be nitrogen monoxide. Second example, we have NO2. So you have one nitrogen and two oxygen. So therefore, its name is nitrogen, not mononitrogen because it's the first nonmetal. Since there are two, so that becomes dioxide. IDE ending, and it's a di because there are two oxygen. Third example, we have N2O3. This time, we say dinitrogen. So still we retain the nitrogen, but since its subscript is 2, then we can already use the prefix di. And then since it's 3, then that becomes trioxide. So trioxide. N2O4, that becomes dinitrogen and tetraoxide because there are 4 and then IDE ending. Fifth example, we have N2O5, so that becomes dinitrogen again, and since it's 5, that's pentaoxide. SF6, we have one sulfur, so that's just sulfur, and then since there are 6, that's hexafluoride. That should be one word, there should be no space, so hexafluoride. And then IF7, that becomes, or that's named as iodine, heptafluoride because there are 7. So you use the prefix hepta. So basically, if you reverse the process, what if you're given the name and then you are to write the chemical formula, then that's easy because the prefixes will guide you as to how many, what should be your subscript value. Remember, like for example, N2O4, if you see, you might be tempted to simplify 2 and 4 because you can divide that by 2, but that's not allowed if you're dealing with covalent compounds, because you know that every number of atom is instrumental in the stability of the structure of your covalent compound. So don't simplify, just follow whatever is the subscript value indicated in the name. Okay? These are some of the examples. So mono, this carbon monoxide. We didn't say monocarbon monoxide. So mono is used only for the second nonmetal element with the chemical formula CO. We also have diphosphorus pentoxide or pentaoxide. That's the same. So that's two phosphorus and five oxygen. Boron trichloride, so that's one boron and three chlorine. Carbon tetrachloride, so that means one carbon, four chlorine. Phosphorus pentachloride, so just phosphorus, that means one phosphorus. Penta means five, five chlorine. Sulfur hexabromide, so one sulfur and six bromine. Iodine heptafluoride, so that's one iodine, seven fluorine. Remember, always take note if these compounds will be mixed, take note that your covalent compounds, these covalent compounds are all made up of nonmetals, which are found on the right side of the periodic table. If you're dealing with ionic compounds, always remember that the metal, the cation, was written first and you need to crisscross. And the name of the ionic was not dependent on this. No prefixes, only for covalent compounds. So always look at your periodic table if you're unsure what type of compound you're dealing with, and I hope that you can get it accurately. Thank you so much, and that's all for covalent compounds.